Welcome. We will work on problems 5 and 6 for the worksheet in this video. So problem 5. How many distinguishable ways, that means ordered ways or permutations, can the letters of the word millimicron be arranged in order? But what we need to pay attention to that if we have, for example, the two L's, they are not distinguishable, they are the same letter. So that reduces the number of options. How many distinguishable orderings for part B of the letters of the word millimicron begin with M and end with N? So let us first start with part A. Let us do some inventory. Millimicron as a word has 11 letters, and it has 2 M's, 3 I's, 2 L's, and one of each CRON. So we will count how many arrangements we can make building the arrangements of the 11 letters letter by letter. So the number of arrangements is so first we choose positions for M's. So that's 11 out of the positions, choose 2. That keeps us with 2 open positions for letters. We choose 3 of them for I's, 9 choose 3. Those are independent choices, so we multiply. Then that leaves us 6 positions for L's. So we have 6 choose 2 choices for positions for L. That leaves us 4 positions for C, for choose 1 position options for that. Then after we place C, that leaves us 3 positions for R, 3 choose 1 options. We place R, that leaves us 2 options for positions of O, 2 choose 1, and that leaves us only 1 position for N, and choose 1 choose 1. And product of these binomial numbers is the answer. So the answer is, and again we can leave it in this unsimplified way, 11 choose 2, 9 choose 3, 6 choose 2, 4 choose 1, 3 choose 1, 2 choose 1, 1 choose 1. So this is a typical problem where you need to count permutations, so orderings of symbols, but there are some repetitions, like we had repetitions of the letters. So for part B, then the arrangement has to start with M and end with N. That reduces the number of letters which are placed to only 1 M, 3 I's, 2 L's, 1 C, 1 R, 1 O, and 9 positions only. So the number of such arrangements are 9 choose 1, choosing 1 position for M out of the 9. When we place M, we have 8 open positions. I choose 3 for placing I. Then that leaves us with 5 open positions. 5 choose 2 for placing L's. That leaves us with 3 open positions. 3 choose 1 for placing C. 2 choose 1 after that for placing R. And then we have just 1 slot open, so 1 choose 1. That 1 slot for placing O. So again, the product of the binomials number at the bottom of the slide is the answer that gives you the count. Very good. So let us move to the last problem on the worksheet, problem number 6. It has a little bit of geometric flavor. So suppose we have 10 points labeled A through J, and they are placed in the plane such that no 3 of them are on the same line, and we are supposed to count for A. How many lines are determined by these 10 points? So what we need to realize that each pair of points determines a unique line. So the answer is 10 choose 2, number of pairs, which is 45. How many of these lines don't pass through A? So we that way we can use only the 9 points labeled B through J. So out of the 9 points B through J, we have 9 choose 2 pairs. So that's 36 lines avoiding A. And now for triangles, how many triangles have 3 of the 10 points as vertices? So a triangle is of course determined by the 3 vertices. We have 10 of them. So 10 choose 2 is the count. 10 choose 3 is the count for number of sets of 3 vertices. That's 120. And finally D, how many of these triangles don't have A as a vertex, so that reduces the number of vertices we can use to 9, B through J. So the answer is 9, choose 3, choosing 3 out of 9 vertices, which comes to 84. So those are the answers for problem number 6. Thank you.